Okay, all right. So shall we start? Okay. So next 3 lectures are important. So we'll try to finish the course on Thursday. Okay, and there are new topics. So please expect a good number of questions in the exam from these lectures. So please be attentive. Okay, so today we'll study this topic of TLS and if time permits about firewall. Yeah. Okay, just give me a minute. Okay, all right. Okay, so these are the contents that we'll take. Now, you are using, all of you are using HTTPS, right? Okay, it means that you are using TLS. HTTP, which is protocol used in browser, uses TLS inside, right? So over the time, most of the websites are supporting TLS. Okay, and it is now advisable that never go to a website that doesn't provide security. S stands for security here, right? When you write a URL, if you use only HTTP, then website is not supporting security, right? So, and then if it's not secured, your connection is not end-to-end secured, then when you get the data from server, okay, there is a possibility that some node in between can corrupt the data or send you malware. Okay, all right. So these graphs show how HTTPS is becoming popular, right? Okay. So and the data is about different browsers and OS, primarily OS. Okay, all right. So this protocol is creating secure communication over the internet. So internet, as you know, has it is provides just a basic pipe and does not guarantee anything. Okay, and it does not also guarantee security. So any node in between can corrupt your messages. Okay, can read your messages. So Mallory and Eve can be everywhere in the internet. You don't know where your data is passing through, how many routers is passing through. It's maybe passing through an enemy's data also. Okay, so this is, of course, is based on SSL, secure socket layer, which was earlier version of this protocol. So from SSL, last version came TLS. Is real world security protocol. It means that it's being used heavily. Okay. Now IPsec we have studied is also being used, but IPsec is network layer protocol, right? So when you use VPN, etc., you use it. Like, you know, you get advertisement for to use VPN. Okay, then you are starting a tunnel from your machine up to a gateway. It's never end to end between two machines. Never. I mean, of course, you can do that also, but you need a hack for that, right? Because IP simply says a network address. It does not talk of ports, etc. But if you start using ports in IPsec, that we call a hack, then we can also provide security. But most of the time, IPsec is used for VPN between one gateway and another. Okay. All right. So however, this works at transport layer. When we say transport layer, it means that it works on top of, say, TCP. Then we will also use its ports. Now, when we are using ports, it means that it is end to end between two end parties. Now, who are two end parties most of the time? See, until you do peer-to-peer communication like Tor or some other protocols, most of the communication, everything else apart from peer-to-peer is client to server. Okay. Now, are we doing peer-to-peer communication now? I'm asking you guys. See, as per IP, any two end that's having IP address can communicate, right? I have an IP address on my Mac, and you are also have IP address based on whatever you are using and where you are. So is it peer to peer or is it client to server right now? Please answer. Any answer is okay.
Peer to peer.
No. It's a good guess, but I would also guess the same thing first. Is a client to server? There's a server in between. Okay, that's reading, that's accepting all my messages, and then you are connected to that server. Okay, it in this case is a WebEx server. Okay, so most of the time we use client server model, right? So most of the time we have to protect, and we are using browsers or apps, right? So it's between a client, say for example, browser and web servers. All right. So where does TLS sits? TLS sits at layer 4.5. Okay, it means that it uses TCP. Okay, so now it's a transport layer. It uses TCP. It does not use UDP. It's not used. Okay. Now, so obviously it will rely on byte stream. So input to this TLS will be byte stream, and out, and it sends byte stream and also receives byte stream. So it delivers to application byte stream and accepts byte stream. For the application, it means that TLS is kind of hidden. It doesn't matter if it uses same IP, same set of APIs. Okay, all right. Now, what does TLS provide then? It provides confidentiality, integrity, and authentication. Remember this CIA model, right? It provides all three between end to end. Remember this. So now we are going to use all the concepts we have studied so far, right? How to achieve confidentiality, how to achieve integrity, how to achieve authentication. You know these three, right? All right. So we can achieve confidentiality, integrity. It means that attackers cannot tamper with your traffic. And one of the attacks which Mallory may try to do is replay attack. And replay attack is something, Mallory, while communication is going on between you and server, Mallory will record everything. Okay, and when connection is over, Mallory will replay that. Okay, now these kind of attacks are called replay attacks. Now, of course, apart from confidential integrity, authenticity is achieved. It means authenticity means that you are talking to a legitimate server, right? When you are talking to, for example, your client machine is talking to Amazon, you know that actually you are sending data to Amazon. Okay. All right. So now, so we can see in internet all kinds of problems can happen at, I mean, like we have seen a lot of attacks. Okay, like DNS server attack and many others, right? Many of these attacks we have not studied as part of our course, like BGP attacks, routing layer attacks, DNS attack, TCP attacks. Of course, we have studied only two. Okay, so now it provides kind of secure communication between end to end, but it does not secure endpoints. Endpoints remains as insecure as it was. So you'll have to do other things to make sure the endpoints are also secured, right? What happens is the server lies or tells, pretends as something else. You can't do anything. Okay, all right. Now TLS has two protocols, two set of protocols. First is handshake protocol and second is record protocol. Now note that if you're designing TLS, what all you are going to do? We looked at the design of IPsec. Similarly, you can think of as a designer what all you can do. See, you are using, see, end person could be anybody here, right? So you are the end person here. Okay. And here is server. It is your node, this server node. Okay, what are you running? You're running an app or you're running a browser, right? Browser or app. Okay, you are connected to Ethernet to IP and then you are running TCP to endpoint. This connection is already established, right? Okay. Now attacks are possible before you establish TCP connection. Now what can happen now? What do you want now? How to achieve confidentiality? Please be fast, huh? How to achieve confidentiality between two endpoints? Guys, are you attending class or what?
Sir, encryption, decryption.
Of course, yeah. So why are you taking so long? So you need to encrypt, and you are not, when you are watching, for example, IPL matches, is not just a small set of bytes you need, right? You continuous stream you want to get, right? So is data can be very huge in number, right? In size. So which encryption method you are going to use? Symmetric encryption. Then in symmetric encryption there are a lot of choices. AES, within AES there are choices. Okay, and it can use DES or whatever. Fine. So there must be something about protocol negotiation. Okay, so you will say, okay, my machine, my browser can only support AES this version. Server will say, oh, fine. So protocol negotiation has to be there, right? What else? Quick. What else is needed? How do you establish? How do you key exchange, right? See, AES and DES both will require symmetric keys on both hands, same key. So it means that there has to be key exchange. Fine. Now, how do you authenticate? This server is actually Amazon.com. No, Amazon.com need not authenticate you. Okay, it could be, it's just, it's just responding to your messages. So but you need to, when you are sending money to Amazon.com, then you make, or any bank, you must make sure that it's actual server Amazon.com, or 2D is not pretending as Amazon.com. Then what do you need to do? What is the mechanism for that? You are using public key of this server Amazon.com. So this public key should come to you. Okay, and then you should ask for certificate of public key of Amazon. So now Amazon should also send public key. So now we have decided few things we have come to know. Symmetric key, say AES, then key exchange or key sharing, we can use RSA or Diffie-Hellman. Then for integrity of public key, you are going to use certificate, digital certificate. What else? Now, how do you achieve? Okay. What else? Availability you can't achieve through this, right? You can't make sure that connection will be, if the memory in between can send RST packet, can disrupt. So a lot of things are still happening in plain. Encryption is, when you're encrypting something that you're not encrypting TCP header, you're encrypting usually data, right? Okay. So RST packet where IP address is also known, ports are also visible. So RST packet can only be sent. Okay, all you want is that confidentiality, authentication, and integrity. How do you know that integrity is there? Authentication we have seen. Integrity. What mechanism we use for integrity?
Mac.
Very good. Thank you. So now this makes the whole protocol. You have designed it already. Now in sequence, first, as we have seen, IPsec's first phase is protocol negotiation and key exchanges. Now once this key exchanges are there, okay, and in between you also do authentication, and then you use MACs. All right, that's it. When communication happens, you are going to use encryption and MAC. All right, so now let's start. So there are two phases here: handshake protocol and record protocol. Agree on protocol. Handshake protocol will decide, or negotiation on protocol. What version of AES, DES, and all that is negotiated. And what is the key size, etc., etc. All are negotiated here. Okay, and then we are going to use public key cryptography for that, for key exchanges. All right, and then perform authentication. All right, and then once session established, then we are going to use encryption and MAC. That's it. All right, so handshake protocol, we are focused only on handshake protocol. So let's look at this way. There are two parties, client and server. Negotiate the version of protocol and set of cryptographic algorithms. So we are talking about handshake protocol, right? Okay, then we are going to, so that there is interoperability, right? Because both ends are using the same set of protocol, same size of keys, etc. Right? Authenticate client and server, which is optional thing. Okay, so now you can use digital certificate. Okay, the protocol version here says that only server authentication is sufficient. Okay, all right, but it can be made both ways. And then use public keys to establish shared secret, which is used for, shared secret is used for encryption and MAC. Now note that we have also studied MAC key and encryption keys are not same, both are different. Okay, so we have to create key for encryption, also we have to create key for MAC. And now note that there is a communication both ways, right? From you to server and server to you. So now we have to create key for this way. Say symmetric key is a key 1, which will use for encryption of data going from one end to another end, and key 2 for encryption of data coming from server to you. Similarly, you need 2 keys for MAC, say I1 and I2. All right, so you need 4 keys now, and that you need to generate. All right, so first step is that exchange hellos. Okay, now assume that TCP connection is already formed. The client send client hello with a random number, 256-bit random number called RB. So RB is sent, is generated, is a random number, is generated and sent to server, is 256 bits long, right? So you can use pseudo random number generator now, and also send the list of supported cryptographic algorithms, right? So it's a negotiation phase. Server sends, replies back with hello. It also sends a key called RS, which is 256 bytes long, and it chooses the algorithm, which set of algorithm client proposes and server chooses one of that. Okay. Now we are using RB and RS, which is kind of nouns or initial IV, okay, to prevent replay attacks. All right. So how we will see replay attacks? We have seen that Mallory in between records everything and replays. Now since these are, once session is over, then this RS and RB and RS have no value, right? Okay. So if she uses the same set of numbers again, then she will not be successful. That's the understanding between client and server. Okay, all right. So this guarantees that two handshake will never be exactly identical. All right. So now what will happen? So now both parties have got RB and RS. This guy also has RB and RS, which are random numbers. Okay, now this guy says that, okay, this is my public key and I am sending certificate of that. Like Amazon.com sends you public key. Okay. Okay, public key we understand, right? Now you receive the public key and I am sorry, you receive the public key with a certificate, and now you want to validate whether this public key is okay. Now you use digital certificate method, which you have studied in detail. Okay, because certificate is issued by some trusted authority, and we use that to verify the certificate, right? Okay. Now after this phase, we know that this key, server's public key is okay, is genuine, right? So it means that now client or that you are talking to actually Amazon.com. All right. Okay. Any question up to this point? So now what happens? Now we have completed the authentication phase. All right. All right. So this is where we are. Now next phase is called pre-master secret. Now we have not generated yet many things, right? We have just got RBRS and that's it. And then public key of server. Okay, now we need to go further to generate these keys. Okay, so we have to use something, right? Diffie-Hellman or RSA such that we generate symmetric keys, right? Okay. Okay. Okay, now we need to do a little bit of authentication. Okay, all right. Okay. So we are going to use RSA and Diffie-Hellman for key generation. All right. So what we are, this phase is called pre-master secret. Okay. Now we are using, we can either use RSA or we can use Diffie-Hellman. Okay. Now RSA method was used earlier in TLS, and nowadays it has been stopped. Okay. However, we'll just look at it how it does, right? So server already has public key and private key. Now note that server is Amazon.com, for example, right? So it will have already generated public key and private key. Okay, and a secret key. All right. So these keys are already there with server. Okay. And the server is going to use these keys, right? Okay. So now this key of public key of server is already known to client because it has come as part of certificate. Okay. So now client randomly generates a random number which we'll call pre-master secret. Okay. And uses public key of server to encrypt it. Okay, now this pre-master secret, which is a random number, okay, which of course client saves, is now sent to server, and server uses his private key to decrypt it. Okay, all right. And now only server has a private key, so server can decrypt it. So basically we are assuming that already server has public key and private key, okay, and using RSA, and as a result of that, uh, uh, you or client knows the public key, and then using that public key you encrypt the random number that you have generated to pre-master secret. Now note that this pre-master secret is going to be used to generate further keys, okay, and then this guy also gets the pre-master secret after decryption. Now only note that only server can decrypt it because only server has the private key corresponding to this. Any question? All right. Okay, so this method is not used, right? Okay. Something that is used is Diffie-Hellman. So server A, so this phase is of course common. Okay, this part of the first phase is common, and then server generates secret A and computes G res for A mod P. You know all these steps, right? So we are not going to discuss this. Okay, and then server signs. When we say signs, it means a digital certificate, right? Using private key. Sorry, digital signature. I'm so sorry. Server signs G res for A mod P with private key. Okay, is shown is a K inverse server. So now what it will generate now? It will generate this secret G res for A mod P. Okay, so it will send this along with, it will get signature. It will use private key and encrypt it, and then it will send this signature along with. Okay, so signature, remember this, then signature alone cannot go. Signature always goes with the main text, because what we are trying to say is that this document is valid. Okay, so the this will go in open, and then signature will also go. Okay, now when you read this kind of sentences, you are generally confused that only signature is going, but please remember this thing. Okay, now client verifies the signature. So what, as a result of that, what client gets it? G res for A mod P. Okay, all right. Now what the why is signing this with, why do we need digital signature? It could have sent G res for A mod P. Anyone? We discussed this point, right? In Diffie-Hellman, there's something called man in the middle attack, right? Remember the diagram? Then Mallory in between intercepting, and then, okay. Now with this, and then we have, there was a bullet point at the end that with digital certificate we can avoid man in the middle attack. So now we can see that here, because if Mallory changes this, then client can always find out, because certificate will not match with the content. Okay, so in order to have integrity of message that is exchanged, that is G res for mod P, we are using digital signature. Okay, all right. Client generates now secret B and compute G res for B mod P. Okay, and client, so now client sends this. So now client and server, as a result of Diffie-Hellman, both of them have this secret called G res for AB mod P. Okay, this step is clear. What is the next step? Next step is additional. Okay, okay, give me a minute. Okay. So this step we have done. Now from this, now what we have, each one has RB, RS and PS. Now PS is nothing but the key that we have derived. Both have the same key, right? The G raised for AB mod P in our case, right? This one. In RSA is different, right? But let's forget about RSA. Let's focus only on Diffie-Hellman algorithm, right? So now we have these three things. V means client and server. From this, it will generate 4 keys as we discussed earlier. Okay, now this method could be using PRNG or something. Okay, now if you want to really know about details how using these 3 methods, each one can generate same set of keys like CB for encrypting client to server messages going from client to server, CS for encrypting uh, server to client messages. When we say encrypting, it also means decrypting at other end, right? So, and then IB for macking client to server messages, IS for macking server to client messages, right? So these 4 values are known to both client and server. Okay, now this is additional step. Okay, now MAC values are known at this point in time. They say, all right, we have done all these exchanges. Okay, now a lot of exchanges have happened in plain text, right? All right, and then there is a possibility that so there might be some corruption of those messages. Okay, because first phase we have not yet created encrypted channel, right? So now let's repeat all these 4 steps and check the integrity using the keys which we have generated now. Okay, all right. So this is just kind of sanity checks that they are going to do. So what will happen now? All right, so now everything is over. The next step is start sending messages. Okay, now at this is overhead in some sense, right? To establish a channel, real end-to-end channel, a secure channel, right? So now you take client is sending message M. What is it going to do? Now we have studied when we are using encryption plus MAC, there are 4 methods, right? And 2 of them are popular, right? And we say MAC and encrypt, encrypt and MAC, and so on and so forth, right? And we have seen at the end encrypt and MAC works better, but here designers have decided to use MAC and then encrypt. Okay, all right, so we'll look at this. So now this phase we have already discussed. This is overhead to establish channel. Okay, now real communication happens, for which you have initiate this communication, right? So message M is to be sent. You get the send message M, take message M, get MAC of that message using some key that you have generated. Okay, which is IB. B is here. Okay, then you get this, what do you call that, message and MACB as a combined thing, and then you encrypt this using secret key of client, right, which you call it CB. Okay, so what we are using is macking first and then combined tuple or combined thing we are encrypting and sending. So we are using MAC and encrypt. Now when this reaches to other end, the server knows CB, so it will get M and MAC of this message using IB. And now what it will do is that it will use this MAC method to make sure that this has integrity. And we have seen this method, right? I mean, use this key to generate MAC and compare, and then you know whether this method match the message has been corrupted or not, right? So MAC, we have seen HMAC and many other methods. The same method we can use here. All right, whatever is defined by algorithm. We are not going to get into details what MAC we are using and so on and so forth, right? Now that's all. That's all. Now the remaining part of the lecture is all about how can you sure you are talking to legitimate server. Of course, we have answered this because server has sent. When we say server, it means that whether public key of server is genuine or not. That's all, right? Okay, so we can see the certificate of that. Certificate will not only tell about whether public key, about the public key, but also about the server, what the server is, right? Certificate is not just only public key, but also server's identity. All right. Okay. So that's clear. How do you secure messages? When we secure, basically confidentiality and integrity. Okay. So attacker doesn't know PS, right? Attacker, I mean, Diffie element, we have seen in case of Diffie element, attacker doesn't know it, right? And now we made sure that attacker also cannot do man in the middle attack, right? So now PS is known only to end parties, that client and server. So it means that only they can generate the keys, right? Both symmetric keys and for integrity check. Okay, all right, or MAC keys, right? So it means that now we make sure that fine, this is client and server's messages are all secure. Replay attack, we have already seen it cannot be done. Okay, all right. Now this thing now why we are using Diffie element instead of RSA? Because Diffie element provides guarantees forward secrecy. Is same as what we are discussing replay attacks. Right? So RSA does not guarantee forward secrecy. Secrecy is not guaranteed, while TLS, Diffie element, TLS guarantees forward secrecy. Please read it by yourself, right? Now, what guarantees are there? Client is talking to legitimate server. This is one guarantee. No one can tamper with the handshake. Second guarantee. And then client and server share the set of symmetric keys, which is unique to connection. So nobody else can corrupt the messages in between, right? What is the efficiency of now? Note that now this algorithm is going to be used by almost every browser. For every time you are communicating, right? You are using TLS. Okay, so it has to be very efficient. All right. So now public key cryptography, of course, there is a cost, but it's not very huge cost, right? Because you are changing you are using Diffie-Hellman, and then you are exchanging keys. Some protocol message exchanges are there, and you have to generate random number, pseudo random number, or etc. But these are nowadays there is a hardware which generates all this, right? So the cost is generally low. Okay, all right. Symmetric cryptography is again low cost. Okay, so basically key generation etc. is done in mostly in hardware nowadays. It's very less cost. Latency is there, right? You will start communication when the first phase is over. Only then your actual data transmission happens. So there is, of course, all this negotiation and key exchanges will have some cost. It some time, right? But it's not much. Now, because of this efficiency, this being used in most of the protocols, unlike IPsec, which has lot more protocols defined, so it's much more complex than TLS. Now, difference between IPsec and TLS is that TLS truly provides end-to-end security from your browser, and from your browser the processes, because use of port is there, right? Actual process, one process to another process, you have communication, right? Secure communication. Okay. Now all these points we have discussed. All right. However, okay. All right. All these points we can see that so nobody can inject the packets. Okay. Of course, when endpoints are malicious, nothing much can be done because you are creating between two endpoints, right? If the endpoint itself is malicious, nothing much can be done. Or the server you Amazon.com is malicious server, then you can't do anything, right? But apart from that, all communications are secured. Yes. And uh, a local network attacker tries to read your Wi-Fi session but can't read TLS messages, right? Now, from now note that suppose you are using within premises Wi-Fi, and then your message goes from your laptop to server and then goes out, and mallory is in between trying to intercept. Okay, she cannot do anything because everything that you are sending is encrypted. Now she can still do some tricks at layer 2, but I mean she can disrupt the connection. Okay, but she cannot do more than that, right? She cannot read what's actually happening, right? So in the network like this, if a tunnel is formed and there is mallory in between, she can inject RST packet, reset packet. Because note that what we have discussed is headers are as it is, right? We are not changing headers. So if mallory can predict, sequence number, source IP, destination IP, source port, destination port, that's called signature of TCP message, and uses RST, then she can disrupt it. Okay, so all right. So using TLS still helps us to overcome lot of lower level attacks, but it does not provide anonymity because client and server's identities are known, right? Because IP packet will contain IP address, then it will also contain ports, right? Source port, destination port, and then certificate can be seen by anybody, right? When mallory looks at the certificate sent by server, it knows that it's whom a client is trying to talk to. Okay, all right. So all these things are known. So there is no anonymity here. Okay. Availability, of course, is not there, right? I mean, RST packet can be sent by MITM and packet can be disrupted, right? So it does not guarantee that your connection will be alive all the time. If they're malicious person, they may disrupt your connection. But remember, three things are guaranteed end-to-end: confidentiality, integrity, and authentication. Okay, all right, remember this. Okay, all right. Application, most of the application on top of TCP today, if they want security, uses HTTPS. Okay, which uses TLS inside. TLS is integrated into this one. Of course, TLS does not depend on application level. See, now you have created connection end to end, right? From one process P1 to P2 here. But something that is going inside, the application is generating what? Byte streams. There can be something here. So like SQL injection, scripting errors, buffer overflow vulnerability. All these are still possible with TLS. TLS doesn't defend against all these kind of vulnerabilities. Okay, let's summarize. There are two phases: TLS handshake, which is most important. It as a process of that, they exchange a random number with each other, and then server sends a certificate. Client knows that server is genuine using, when it decrypts certificate and comes to know the public key is genuine. Then they use Diffie-Hellman algorithm to create a secret, which is called pre-master PS. What is it? Just a minute. Yeah. Wow. This phase, right? This and that. Okay. Yeah, this phase, right? Okay. Next phase. All right. So we are here. All right. And once, as a result of that, all of these create 4 set of keys. 2 keys for symmetric key encryption, 1 key symmetric key for this direction, other key for sending data in another direction, and 1 key for MAC, other key for MAC in other direction, right? So 4 set of 4 keys are generated, and then communication happens. All right. So that's about TLS. So please read it from these slides and also from the book. Also is given in Berkeley's website, right? They have a book and you can read the book. Okay, little bit about firewall for next 3-4 minutes. What is a firewall? Your machine is having firewall, right? I hope if you have virus protection software, and then it provides you with a firewall. The server in your institution will have also a firewall, right? What is a firewall? It's like a sentry. I mean, you have an institute, there's a campus, right? Okay, and there is only one gate, and there is sentry here or security guards, a security officer. What do? They do the role of firewall. Okay, somebody who is coming inside, it will check the ID card and let the person go in. Anybody going outside, they may let the person go. Okay. Now here the policy is with respect to checking who is coming inside. Now many institutes or many organizations, when you go out, then also you have to swipe in the card. Okay. Now there can also be some policies here. I mean, it's all policy driven. Policy could be, if you are going after 10 p.m. in the night outside campus, then sentry will say no, you cannot go. Okay, so there can be many rules, right? So firewall is actually right in the entry point of your network. Okay, this point we have know that internet provides lot of points of attack, so we need to protect that. And this is nothing but something called mediation point. Okay, so this is your network, then everything that's passing through it, all IP packets have got to go through this firewall, and everything that's going out also has got to go through this firewall. So it does the complete mediation. This concept we have studied earlier, right? And it's based on the policy. Okay. So the policy can be outbound policy, means everything that's going out is allowed to go out. Inbound policy is that what traffic is allowed to go in, like your ID card. Or now in case of firewall, you can use what all you can use. You can use IP source, IP address of source, IP address of destination, port number of source, port number of destination. Then you can find out whether the TCP connection or UDP connection. Okay, you can also use from this what is subnet address and so on. So what are these are the basic things. Based on that, this data you can create set of rules. Now somebody, if your security guard knows that one guy from the village who is rowdy or malware kind or mal person tries to enter, they can stop it. Okay, because the person will not have ID card, or these guys may have some signature of that person with a photo or whatever, and then stop it, right? Okay, so firewall does the same thing. If malicious sources are sending information, okay, and firewall comes to know, or firewall is intelligent enough, then can block those, right? Okay, all right. So we have outbound policy and then inbound policy, right? Okay, all right. So for example, allow inbound possible to certain or trusted services like SSH. All right, or deny. So basically, when somebody is coming inside, then you have to be more careful than somebody is going outside. So you can say outbound policy can be default. Any traffic that's going out can be stopped. While traffic is coming in, you can have a rule. Okay, all right. So we can have default policies, which is default allow policy. Okay, so we can say all traffic that's coming inside are allowed excepting for somebody who is in denial list. Like your security guard will have names of certain set of people. Like even in airport, they have a list of people who are not supposed to fly out of country. Similarly, your security guard will have set of people who are not allowed to come inside. Okay, so all other people can, if my name is not there, I'm coming from Bangalore, I'm allowed. Okay, as simple as that. Okay, default deny policy is that you deny everyone. So when I'm trying to get into your office campus, they will deny me until unless my name is there in the list. Okay, all right. So what default policy is best? Default allow policy is more flexible. Default deny policy is conservative but more secure. All right. Now this thing, your security guard can be a just very plain simple guy who has put into duty just today, has no history, okay, and also doesn't want to learn. So it can do only one thing, it can check the ID card and let person go in out. Okay, similarly here we can have stateless filters or stateful filters. Filters are nothing but firewalls. Okay, stateless will say that just I will look at only ID card, like a signature of IP packet, a signature of the packet, right, which is all these four things: IP source, IP destination, IP source, port destination, port, TCP, UDP, or what else is using, right? So something like this. Based on that, it can accept or reject. All right. So they have no history and no intelligence, right? Okay. But stateful will have lot of history about. They are more intelligent, right? Okay. So it will say that, for example, we can create set of rules like allow TCP connection from this IP address. Okay, and any port, anything can come there, or any port, any process can send packet to. And if this communication from 4.5.5.4 is happening to 3.1.1.2 at port 80, then allow. Then we can have a lot of rules, like anything that is coming from outside is that is coming for port 80 in a server, please allow. Okay, so all these kind of rules we can create in a stateful filter. All right. Please go to this PPT. I will surely ask at least one question. Okay, this is very simple. It does not require any deep knowledge of anything. Okay, all right. Please go through this. I don't think we'll have time because next two lectures will be on crypto. So what we have studied today is that we have studied mainly TLS and some aspects of firewalls. Okay, all right. Any question? Okay then.